Hi there! Today we're gonna solve some math problems using Python and using the math function only to solve the problems that will be presented. So we're just only gonna solve 7 problems so that this video would be like shorter, and then we'll see where we would go. Okay, so the first problem states that what is the smallest number of coins that can be represented in $1.56 using quarters, dimes, nickels, and pennies if all coins must be represented. So in this problem, you need to have the modulus to find the remainder of said coin since we're looking for the smallest. So from there, we use the math, from math, import function. We need to import all of the functions because I don't remember. And our dollars that has been given is 1.56. There. And from that, we need to have our value to dollars times 100. Or, yeah. We also need to round this so that you can like have a full integer. We're just looking for how many coins, not how much coins. We need to round this. The function round is actually just to round it into an integer. So for the dollars, the value of the dollars is divided by 100, which just converts it back. But we need to find the modulus, or how much of the dollars. So we have value equals to the value modulo the dollars. Now we could use this equation, we could use this argument, but there's a quicker way which has been taught. You have modulo equals value of modulo equals 100, which can be stated as value equals to the value modulo 100. It's just taking back the dollars value round here. So the value here, this is the new value of the value here. So the value modulo equals to the modulo of value of 100 goes back, and it's the new value. So that's the technique there for Python. It's the same with quarters. Goes to the value of here, divide by 25 quarters. Yeah, and the value modulo equal to 25. That's it's the same here. Value is equals to value modulo 25 for quarters. So it goes back here. This is the new value. This is the new value 25. Next is the dimes. Is equals to value divided by 10 for dimes, and then the value modulo equal 10. Nickels is value divided by 5, value modulo equal 5. We're just getting the remainder. Okay, we're just getting the remainder and divide it by how many nickels. Yeah, how many nickels are there for 1.56? Or no, the value of the nickels, I mean, the numeric value of it. Then pennies is just the value. It's just pennies it's just this. It's just the how it's just the an equivalent of 1 peso for it. Alright, now we go to our print statement. Print the smallest number of coins representing you need to put the curly braces here so that we can just put another uh letter the statement their format, put their dollars, and then print. This is gonna be a long print, so bear with it. Now we're gonna use int, because if we're not gonna use int, it's gonna be a float and it will upset the original question, of which number of coins, for not the value but the number of coins. So that's why we are using as int, so that it won't have a decimal quarters, as advised by others. Quarters, print and dimes, print and nickels, uh nickels. Then the last one, print and pennies. Pennies. Alright, now let's see. Oh, quarters, print, spacebar called quarters. Is it quarters? Oh yeah, it's quarters with an S. There we go. The smallest number of coins representing 1.26. I forgot to put dollars. Dollars there. 2 quarters, 0 dimes. 2 quarters is just a dollar. Yeah, 2 nickels and 2 pennies, and one nickels and 1 penny. Okay, so we're going to the next problem, which states if the surface area of a spherical tank is 2000 square meters, solve the volume of the sphere. So the volume of the sphere's formula is V is equal to 4/3 times pi times the radius cube. So we need to convert the square meters first into the radius. To do that, we need to have we need to convert the area of square meters into radius, which is by squaring them and dividing by pi and squaring them. So from that, import this one. That should be like the default thing. Our area for square meters is equals to 2000, and the radius is equal to sqrt, square root of the area, divided by pi. That's a radius. Now we can solve for the volume, which is the 4/3. 4 divided by 3 times pi times the radius cube. There we go. Print the volume of the sphere. Sphere is volume. Now it's gonna be a float. Yes, 67,283.53. So what I like to do is just do this. Curly braces. Dot. Oh yeah. Curly braces 2f. Cut it off. So we could format it to 2 decimal places only, or 4 decimal places. That format the volume, or we can have like 3 or 4f here. See, 67,283.5339. That's number 2. That's our the volume of our sphere. Next is the volume of a right circular cone of the radius 5 meters and height of 6 meters. So what we're gonna do there is to thus use the volume of the circular cone, which is volume is equals to pi r squared times the height divided by 3. So it's just a simple import math. Our radius, which will be the variable r5, height is equals to 6, and our volume is equals to pi times r raised to 2 times h divided by 3. So print the volume of the right circular sphere is a cone. Circular cone, yeah. Cone is volume. Yeah, there. So it's too long. The decimal is 157.08. We're just gonna use 2f. Cut off that. Format the volume so that you can have 2 decimal places. There we go. Yeah, 0.8. The next problem is this the fourth problem? Yeah, it's the fourth problem. Is find the volume in cubic meter of an open top box having dimensions of 200 cm by 300 and by 50 cm. So I assume that's the volume of length times width times height. It's similar to a cube, but it's not equal sides. So for this fourth problem, we are gonna have the math, import math. So I assume the length is denoted by L is 200, width is 300, and the height is 50, all denoted by cm. And then our solution, it will be the volume equals to length times width times height. Print the volume of the box. Volume of an open top box is cm form. Forgot that format. Dot format volume 6,000. Oh wait. Yeah, 3,000. 300,000 centimeters. Then okay, we're gonna pause here for a while, and we move on to our next problem. I hope you guys do understand. Um, if there's any mistakes, please let me know. And problem 5 is a quite tricky one, very tricky kind of physics problem. I was never the kind to be great with physics. I hope it is correct. So a car accelerated from rest and reached the top speed of 120 miles per hour in 10 seconds. Solve the acceleration of the car in kilometers per hour squared. So we need to convert the 120 miles per hour to kilometers per hour. So what I did is the acceleration of the car. We import from math, import the functions. So the formula is that the initial velocity and the final velocity minus the initial velocity divided by time, so that we can get the acceleration of the car, since that's what the problem is asking about. So our initial velocity is from rest. Initial velocity is equal to 0, starting from rest. Then our final velocity, it reached the final velocity at top speed of 120 miles per hour, and our time is from rest to the destination. It's equals to 10 seconds. It's seconds, okay. So we need to convert the final velocity to kmh first, to kilometers per hour. So mph to kmh is equals to the final velocity times 1.61, which is the unit, the number unit. Then our acceleration solution, we get that converted value, velocity, and divided by to minus the initial velocity divided by time. Then print acceleration is equal to, and then put the acceleration, and 19.32, that is the acceleration of the car. Question 6 is question 6 is a body is dropped from the building and reach the ground in 8 seconds. We have to find the height of the building and the velocity of the body as it hits the ground. That is problem 6. So what I did was we have to import the function from math, and then and then let's see what our given is. Okay, this question is kinematics. It involves gravity and acceleration. So our time is 8 seconds. That's the given. But the hidden unit, the hidden number here is the acceleration or gravity, which is 9.8. Positive because it's going down. And our initial velocity, which is denoted by u, will be 0 because it started from rest. And then we now have to calculate our height, which is needed for the velocity. So our height is denoted by h, simple h, is equal to the initial velocity times the time plus 1/2 times the gravity or acceleration, which is 9.8, and times the time raised to 2 times the time raised to 2. And then if we get that, we now can calculate the the velocity, which is v noted u, initial velocity, plus a, which is the gravity, times the time. There we go. Print statement. The height of the building is, and then you have the height and print the velocity of the body when it reaches the ground is the velocity. Yeah, the height of the building is 313.6 and the velocity of the body when it reaches the ground is 78.4. That's problem 6. Now, problem 7, which is a very interesting problem. We need to find the limit of two equations, which is x squared minus 25 divided by x minus 5 as x approaches 5. So if you write that, that's the limit of x approaches 5 equals to x squared minus 25 divided by x5. And then the x squared minus 25 would be separated or factored to 2x minus 5x plus 5. So how do we do that in Python? Well, there is somewhat of a similar library. It's still from math. From math import function. But instead of math dot limit, it provides more detail on what should be done and what you need. So this is similar to the math function, but it's still math function. It's just a iterative. It's like a somewhat of a what's this, copy of it, but more detailed. It's simpy, which is from math, from the math modules. They separated it and then put more details into it. So how does this go? How does one solve a limit with Python? So in the syntax, in simpy syntax, x is equals denotes the x. X approaches this, or x as the symbol. X is our symbol as x. It could be like T, H, or anything, but that's our x symbols. And then our y and our f, that's our expression. This is where we put our sin costant expression, or e, or anything related to the limit that you want to solve. In this case, it's x squared minus 25 divided by x minus 5. So that's our expression, x minus 5. And then the next syntax is our y. This is our x approaches what? X approaches to infinity or anything. This is our limit. Limit of f of x. Yeah, no, f. The limit of f, our expression, as x approaches, it's supposed to be 0, but it's 5. That's what the problem calls for. And then now we print the limit is, then we put here y. It's gonna be 10. There we go, see? 10. That's the limit. This is what simpy is for. It's from math module. It's from the math module, but they took it to the next level. So to recap, this is our x symbol. What our symbol is x, y, h as x approaches what? Our expression, and then our limit. The limit of this expression as x, or approaches, and then the last number what you want the limit approaches to be. And then that's how the library gets the limit. Okay, I think we have finished all 7 problems, and I hope you have enjoyed listening and watching, and have a nice day. Till next time.